Welcome to Alphanumeric Tricks. In this video, we are going to see the topic Problems under First Order Nonlinear Partial Differential Equations. Under that, we are going to see how to get the solution of type 2 problem, that is Clairauts form z is equal to px plus qy plus f of p comma q type of problems. And last video also we have seen that how to get the solution of Clairauts form type of problems, and this is the continuation of the previous video. The link for previous video is available in the description box. If you want, please have a look on it. Now we are going to see how to get the solution of these two problems one by one in this video. Let us see how to get the solution of z is equal to px plus qy plus p squared minus q squared. Number the given problem as equation 1, and first problem is available in the previous video. That is the identification of the problem type is very important. So you have to identify the given problem correctly. That is here in this problem, is it p, q, x, y, all the terms are present with this form. Is it is there is equal to, is it is equated to px term is separately there plus qy term is separately there plus terms containing p comma q is there. So this type is occur, then you can easily say that this is of Clairauts form. Okay, once you identify the type of the problem using corresponding working rule, we can easily find out the solution. Okay, so the identification of the problem is problem type is wherein first order nonlinear partial differential equation is very important, and you have to remember the working rule for each and every type. Okay, and then we can easily get the solution for this. Now we are going to see how to get the solution. And here the problem is solve z is equal to px plus qy plus p square minus q square, like that it is given. So you have to find out complete integral, singular integral and the general integral. Suppose your problem is asked to find out the complete integral alone, that is find the complete integral of z is equal to px plus qy plus p square minus q square, like that the problem is given. In that case, you have to find out the complete integral alone, that is enough. Suppose your problem is asked to find out the singular integral alone. In that case, you have to find out the complete integral as well as the singular integral, because using complete integral only we can able to find out the singular integral. Okay, and in the same way, suppose your problem is asked to find out the general integral. In that case also you have to find out complete integral and the general integral. No need to find out the singular integral, because using complete integral only we can find out the general integral. That you should remember. Now we are going to see how to get the complete integral for this problem. Before going to start this complete integral, you have to write about that is the given problem is of which type. Okay, so this is of the form Clairauts form, z is equal to px plus qy plus f of p comma q. That you should write in your solution. This gives the more clarity in your solution. Okay, now we have to find out the complete integral for the Clairauts type of problems. Complete integral is very easy, that is by substituting p is equal to a, q is equal to b in the given problem, we can get the complete integral, that is z is equal to p is replaced by a here, so a into this x plus q is replaced by b here, so b into this y plus p is replaced by a, so a squared minus q is replaced by b, so you have b squared. So z is equal to ax plus by plus a squared minus b squared is the required complete integral. Number that equation as 2. Okay, here a and b are arbitrary constants in our problem. Now we are going to find out the singular integral. That is solution for, that is finding singular integral is you have to use the working rule for finding the singular integral. What is the working rule for finding singular integral, that is you have to differentiate the given complete integral with respect to the available arbitrary constants a and b, and you have to use the rule dou z by dou a is equal to 0 and dou z by dou b is equal to 0. This is obtained by differentiating z partially with respect to the available arbitrary constants in the complete integral and equate it to 0. Then you can get the rule, and using the differentiated term and this rule eliminate the arbitrary constant can give the singular integral. Okay, now you have to differentiate this equation to, that is a complete integral partially with respect to a. Then you have dou z by dou a, z is differentiated with respect to a, so dou z by dou a is equated to 0 is equal to differentiation of ax with respect to a becomes x, because x is constant, into differentiation of a with respect to a is 1, plus differentiation of by with respect to a becomes 0 because by is constant, plus differentiation of a squared with respect to a becomes 2a, minus this minus differentiation of b squared with respect to a is 0. So we have x plus 2a alone is there is equal to 0. From this, when you taking plus 2a to your other side, it becomes minus 2a, which is the value of x. And here, when you taking minus 2 to left hand side denominator, we can easily find out the value of a, which is equal to minus x by 2. Now, you have to differentiate again this complete integral partially with respect to another arbitrary constant b. So, in that case, you have dou z by dou b, which is equated to 0 using this rule, is equal to differentiation of ax with respect to b becomes 0 because ax is constant when you're differentiating with respect to b, plus differentiation of by with respect to b is y because y is constant, and differentiation of b with respect to b is 1, plus differentiation of a squared with respect to b is 0, minus differentiation of b squared with respect to b is 2b, and from this, that is after differentiating this, you get y minus 2b is equal to 0. And here when you're taking minus 2b to other side, it becomes plus 2b, and which is the value of y. From that, we can find out the value of b by taking 2 to your left hand side denominator. So b is equal to y by 2. Now look at these two equations. Here a value is readily available and b value is also known to us with independent variables and dependent variables. So using that, you can substitute this in the complete integral and simplify that, you can get the solution. Now we will see the simplification, that is we have to substituting that a is equal to minus x by 2 and b is equal to y by 2 in the complete integral to z, that is z is equal to ax plus by plus a square minus b square. Then we will see the simplification now. Z is equal to a is replaced by minus x by 2 into this x, plus b is replaced by y by 2 into this y, plus a here is minus x by 2 the whole square, so it becomes x squared by 4, minus square becomes plus, and by the whole, that is b is y by 2 the whole square, so it becomes y squared by 4. Okay. Now we have to simplify this term. Here look at this, minus x into x, you have a minus x squared by 2, and here you have x squared by 4 is there. So you have to combine these two terms and take the LCM for this 2 and 4. So when you're taking LCM for 2 and 4, it is 4, and to compare this, to make this to 4, this 2 to 4, you have to multiply and divide by this by 2 without changing this value. So this becomes 4 and the numerator becomes minus 2x into x, it becomes minus 2x squared, and plus this x squared divided by this 4. Okay, plus similarly y squared by 2 minus y squared by 4, LCM is 2 and 4, LCM for 2 and 4 is 4. So you have, that is your y squared, that is to make this to 4, you have to multiply and divide by 2. So 2y into y, you have to 2y squared minus this y squared and divided by this 4. Now you have to simplify this. What is minus 2x squared plus x squared? It becomes minus x squared plus 2y square minus y square as you have y square by 4. So when you're taking 4 to this side, it becomes 4z is equal to y square minus x square. So which is the required singular integral. Okay, and it is free from the arbitrary constants a and b. Now you have to find out the general integral. How will you get the general integral? That is, what is your working rule? First you have to eliminate, that is reduce, not eliminate, reduce the two arbitrary constant in the complete integral to single arbitrary constant with the help of one constant should be written in the function of another one. That is, using this substitution, b is equal to phi of a in this complete integral 2. That is, either you can substitute b is equal to phi of a or you can a is a function of b, that is a is equal to phi of b. Both the ways you can do it. Okay, now we are taking b is equal to phi of a, that is b is a function of a. Now we have to substitute this in equation 2, that is your complete integral. So z is equal to ax plus b is replaced by phi of a into this y plus a squared minus b is replaced by phi of a the whole square. Now two arbitrary constant in the complete integral is reduced to single arbitrary constant after this substitution. Okay, now number that equation as 3. You have to differentiate this equation partially with respect to the available arbitrary constant, that is single arbitrary constant a. Suppose you are using a is equal to phi of b instead, then in that case you can get z is equal to all the terms are in terms of b. So in that case you have to differentiate this with respect to b. But according to our substitution, b is equal to phi of a, all the terms in this equation are reduced to, that is equation 2 is reduced to in terms of a. So you have to differentiate this with respect to a partially. Differentiating this with respect to a, you have dou z by dou a is equal to 0. Using that rule is equal to differentiation of ax with respect to a becomes x, because a with respect to a is 1 and x is constant, plus what is phi of a into y, differentiation with respect to a, y is constant, and differentiation of phi of a with respect to a is phi dash of a, plus differentiation of a squared with respect to a becomes 2a minus phi of a the whole square, differentiation is 2 into phi of a into phi of a, differentiation is phi dash of a. Okay, number that equation is 4. Now using 3 and 4, we have to eliminate the arbitrary constant a. We can get the general integral. Okay, here you conclude your result like this, because we can't write the simplified answer like a singular integral, because the function b is equal to phi of a, that is the phi of a value is not known to us. Okay, that is assumed function here, and in our problem also it is not given the value of this phi of a, so we can't reduce the given problem like your singular integral without that a. Okay, so we can't reduce that without knowing this phi of a. So we conclude your result like this. Eliminating a between 3 and 4, we get the general integral. Okay, so this is the way you have to conclude. Now we are going to see the next problem. Solve z is equal to px plus qy plus p square q square. Number the given problem as equation 1. Here also z is there, and that is z, x, y, p, q, all the terms are present, and here you have z is equal to equated to px separately, and plus next term is qy separately there, plus pq term is separately there. So which is type 2 problem, Clairauts form. Now you have to find out the solution. Here the problem is asked to find a solve, so you have to find out all the 3 solutions, that is complete solution, that is complete integral, and singular integral, and the general integral. You have to find it out. Now we see how to get the complete integral. That is solution for procedure for complete integral is very easy. Just you have to replace p by a and q by b in the given problem. Before that you have to write the problem is of which type. This is of the form Clairauts form, z is equal to px plus qy plus f of p comma q. Now you have to replace p by a and q by b in the given problem to get the complete integral. Then your equation becomes z is equal to here p is replaced by a, so you have a into this x plus q is replaced by b, so b into this y plus a square b square, which is your required complete integral. Number that equation as 2. Now a and b are arbitrary constants in our problem. Okay, and now we have to find out the singular integral. How will you find out the singular integral? That is, you have to differentiate the complete integral partially with respect to the available arbitrary constants a and b, not the independent variables. Okay, and you have to differentiate this with respect to the arbitrary constant and equate the rule, use the rule dou z by dou a is equal to 0 and dou z by dou b is equal to 0. Here also z contains two arbitrary constant a and b, so you have to differentiate z with respect to those two constants and equate it to 0. That is our rule, and using this rule and the differentiated term we can find out the singular integral. Okay, and one thing you should remember, singular integral exists for Clairauts type of problem. Okay, now you have to differentiate this complete integral to partially with respect to a. In that case, you have differentiation of z with respect to a is dou z by dou a, which is equated to 0 is equal to differentiation of ax with respect to a becomes x, because x is constant, and a differentiation with respect to a is 1 plus differentiation of by with respect to a becomes 0 because by is constant, plus differentiation of a squared b squared with respect to a we have to do it, and b squared is constant when you're differentiating this with respect to a, so write as it is, and differentiation of a squared with respect to a is 2a. Okay, which is equal to, that is, from this you can write plus 2ab squared to other side, it becomes, that is, you get minus 2ab squared, which is the value of x. Number that equation as 3. Now you have to differentiate equation 2, that is a complete integral partially with respect to another arbitrary constant b. So in that case you have dou z by dou b, which is equated to 0 using this rule. So you have a 0 is equal to differentiation of ax with respect to b becomes 0 because ax is constant, plus differentiation of by with respect to b is y alone because y is constant, and b with respect to b differentiation is 1, plus differentiation of a squared b squared with respect to b is a squared is constant, right as it is, and differentiation of b squared with respect to b becomes 2b. Okay, from this you have to take this plus 2a squared b to other side, it becomes minus 2a squared b, which is the value of y. Number that equation as 4. Look at the equations 3 and 4. When you're taking one b2 left hand side denominator in equation 3 and a2 left hand side denominator in equation 4, your right hand side terms are equated to minus 2ab. Both are equal, so we can equate this term. Okay, so from that, taking a and b to left hand side, we can write this to be x by b is equal to y by a. Here when you're taking one a to other side, it becomes minus 2ab, so y by a is equal to, both the sides are equal after taking a and b, which is equated to minus 2ab. So we can get the ratios here, and this ratio is equated to some other constant 1 by k. Okay, so we have to find out that we have to find the solution. We have to write like this. Okay, we have to find out the constants a and b. You take this to be some other constant 1 by k. Instead of this 1 by k, you can take k also, but here the first two terms x by b and y by a are in terms of fractions, so you have to write this also in fractions. Then you're finding the constant becomes, simplification becomes easy. Otherwise the simplification is a little bit lengthy. To avoid that, we have to take this equated to another constant to be 1 by k. Okay, now equating first and the last ratio, we can get the value of a, and equating second and the last ratio, we can get the value of a. For equating first and the last ratio, we can get the value of b, and equating second and the last ratio, we can get the value of a. Now we will do it. that is x by b is equal to 1 by k. From this cross multiplying you get b is equal to k into this x, you have kx. Okay, similarly y by a is equated to 1 by k. In that case you have to cross multiply this, y into k, you have yk is equal to a, so a value is equal to ky. Compare this a and b, that is look at this a and b values. Here in previous problem, a and b values are readily known to us, and substituting this in the complete integral and simplifying we get the singular integral. But whereas here a and b is constant, is value is known to us, but a and b are in terms of the another constant k, so we have to find out this k before going to substitute this in the complete integral. Now we will see how to get the value of this k. For that you have to substitute this value, that is substituting this a is equal to ky and b is equal to kx in equation 3. Okay, so we have x is equal to 2, that is 2 value minus 2 into a is replaced by ky and b is replaced by kx the whole square, or it is equal to minus 2. Here you have a k squared into k, you have a k cube into this x squared into y, you have to write it. Okay, so from this x, and that is where we have to find out the value of k cube now. So your k cube is taken to one side and another terms minus 2 x squared y is taken to the left hand side denominator. So you have a k cube is equal to that is minus x by 2 x squared y, you have x get cancelled, so after that you have k cube as minus 1 by 2 xy. Okay, now we know the value of k cube also. A and b values are known to us. Now you have to substitute these values in your equation 2, that is a complete integral. Z is equal to ax plus by plus a square b square. Now we are substituting a and b values. Z is equal to a is replaced by ky into x plus b is replaced by again kx into this y plus a squared, that is a is replaced by ky the whole squared into b is kx the whole squared. Okay, now we have to simplify this. kyx you have a 2kyx plus k squared into k squared, you have k power 4 into this y squared and x squared. Okay, so from this you have to substitute the value of k cube. For that you have to write this k power 4 as k cube into k and substitute this k cube value. So you have 2kyx, k cube is replaced by minus 1 divided by 2xy into 1k, that is k cube can be plus k cube into this k cube is replaced by this value and k is as it is, and y square into this x square. Here xy get cancelled. What is the remaining term? 2kxy minus kyx by 2. So you have to simplify further. It is taking LCM for this. 2 into 2 is multiplied here, so 4kxy minus kxy divided by 2, that is 4 minus 1, you have a 3, so 3 by this 2 into this kxy, and here the constant k is present here. We know the constant k cube value, so to apply this directly here you cubing on both sides, so you have z cube is equal to 3 cube is 27, 2 cube is 8 into k cube x cube y cube. K cube is replaced by minus 1 by 2 xy into this x cube y cube. Okay, because we are cubing on both sides, and this xy get cancelled with this xy, and left out term you have as minus 27 by 16 into this xy get cancelled. After that you have x squared into y squared, or you can take this 16 to other side, it becomes 16 is z cube and minus 27 x squared y squared is taken to other side, it becomes plus 27 x squared y squared equated to 0, which is your required singular integral after eliminating the arbitrary constants a and b. Okay, now we have to find out the general integral for this problem. General integral is simple, that is the same lines you have to follow. You have to write one constant as a function of another one in equation 2, that is you have, so what is your constant available in equation to complete integral a and b? So you have to write either a is a function of b, that is a is equal to phi of b, you have to write it, or b is a function of a, that is b is equal to phi of a, you have to write it. So here we are using b is equal to phi of a. Substitute this value in equation to your complete integral, then you get z is equal to ax plus b is replaced by phi of a into y plus a squared into phi of a the whole square, b is phi of a the whole square. Now your two arbitrary constant in complete integral is reduced to a single arbitrary constant a. So you have to differentiate this with respect to that arbitrary constant a. Then you have dou z by dou a, which is equated to 0, is equal to differentiation of ax with respect to a becomes x, because x is constant and a with respect to a differentiation is 1, plus phi of a into y with respect to a is y, you have to write as it is, and differentiation of phi of a with respect to a is phi dashed of a plus a squared into phi of a the whole square is differentiated with respect to a. Here you have to apply UV rule because product of two a terms is there. So you have to first term write as it is a squared into differentiation of phi of a the whole square is 2 into phi of a into this derivative for phi of a, it becomes phi dashed of a plus phi of a the whole square, that is second term you have to keep as it is, into differentiation of a squared is 2a. Number that equation as 4. Now using 3 and 4, you have to eliminate the arbitrary constant a, we can get the general integral. Here also, and for all the problems, general integral we can't give the simplified result like your singular integral, because the unknown function is not known to, that is the function phi of a is not known to x, not known to us, because this is the assumed function by assumed function. So that's why we can't write the simplified answer. Okay, so you conclude your general integral like this, that is enough. That's all for today's video. If you have any doubts in this, please provide in the comment section. Thanks for your time and thanks for watching. We will see in the next video. Thank you.